Number 59 is again asking us for the equation of a tangent line to this explicitly defined equation at the point 2, 4. So to find the slope of our tangent line, we got to start off with our derivative. Now, this is a problem I probably shouldn't have assigned because it technically requires a concept we're not learning until section 3.9, but I'll walk you through it here real quick. You guys learned early on in this chapter that the derivative of e to the x is just itself, e to the x. In a more general sense, which we'll get into in 3.9, the derivative of e to any power is still e, the same base, to the same power, 2x minus y, multiplied now by the derivative of that exponent. And since this exponent is a binomial, let's take its derivative term by term. The derivative of 2x is just 2, and then minus the derivative of y is dy dx. So that's kind of the chain rule coming into play here when we're taking the derivative of an exponential function. Okay. So that's the derivative of the left side, equals, and on the right side, we have a fraction with variables on both the top and the bottom. So that derivative is going to require the quotient rule. Here we go. Bottom, y, multiplied by the derivative of the top, which is 2x. That looks prettier if I put it in front. That's bottom times derivative of the top. Minus the top, x squared, multiplied by the derivative of the bottom, dy dx, all over the bottom, y squared. Okay, and that is our derivative on the right-hand side. So this is a little bit of a mess here, everybody. I don't particularly like the way this one looks. We've got to try to isolate now that dy dx if we wanted to do it that way, or it's always possible that it would be easier here just to go ahead and put the 2 in for all the x's right now and the 4 in for all the y's and see what happens at that point. Yeah, you know what? I think I see something nice here. I'm going to do that. I'm going to go ahead and I'm going to take this entire line right here and evaluate it at the ordered pair 2, 4. So let's see what happens on the next line here, guys. E, and this is what I saw that I thought was kind of cool. The 2x, that's 2 times 2, which is going to be 4, minus 4, gets us an e to the 0 power, which is just going to equal 1. That gets multiplied now by 2 minus, we don't know what dy dx is, that's what we're looking for, so that has to stay there. All of that equals, let's see what's going on here, 2 times x times y. 2 times 2 is 4, times another 4 is going to give us a 16 there. Minus x squared is 4, and there's a dy dx right there as well. All over y squared, which is going to be a 16 here. Okay, so where are we going with that? This e to the 0 here is just 1, and 1 multiplied by anything, we can just forget about that. I am going to multiply both sides of this equation, though, by 16. That's going to give me a 16 times 2 minus dy dx is equal to 16 minus 4 dy dx. All right, I think I see where this is going here, guys. I want to scroll here a little bit. There we go. That's what I was trying to do. All right, and let's keep going with this. I'm going to distribute that 16 here and get a 32 minus 16, why did I write it that way, dy dx, is equal to, right side will just stay the same, 16 minus 4 dy dx. And I'm going to bring this 16 dy dx over here, bring this 16 over here. 32 minus that 16 is going to give me a 16 on the left. Negative 4 dy dx plus 16 dy dx is going to give me a 12 dy dx. And so we're just going to divide both sides by 12 right here. And what we really have is our derivative, dy dx, evaluated at the ordered pair, shoot, I think it was 2, 4. I had that wrong. I'm glad I checked. Evaluated at the ordered pair 2, 4 is equal to 16 over 12. Let's divide a 4 out there and get 4/3. Now, this is not my final answer here, guys, but when I've evaluated my derivative at the point of tangency, this is the slope of your tangent. So, where are we going now? I'd go to point slope form. Here we go. Y minus the y coordinate of your point of tangency, y minus 4, equals the slope of your tangent, which we just found to be 4/3, times in parentheses x minus the x-coordinate, which is 2. Nothing pretty is going to happen by distributing that 4/3, but that's what I tell you guys normally to do, so let's go do it. That's a 4/3 x minus 4/3 times 2 is just 8/3. And then we'll add 4, but I tell you what, I'm going to make that 4 a 12/3 so that I can put those two terms together and get my answer in slope-intercept form. Y is equal to 4/3 x, and then it looks like a plus 4/3. And it's not very pretty, you guys, but that, I think, is the best answer that we're going to be able to come up with for this problem right here. So let me double check the solutions manual. I don't even remember what problem this was, you guys. Problem number 59. There we go. And that, yep, y is equal to 4/3 x plus 4/3. Ugly, but that's what it is.